Today we're in lesson 7.7, functions and equations. A couple things you need to know about a function before we get started. The first thing you need to know, I'm going to start with the second bullet point, that x values are what we call our input. X values are the input, and a set of x values is what we call the domain. Our y values are our output, and a set of y values in a table, like we'll see in a minute, is what we call the range. All right, so x values are the input and y values are your output. Where have we seen x and y values before? You saw them recently. Where have you seen them before? Yeah, very good. When we're graphing the coordinate plane, right? Our quadrants, we had ordered pairs that had x and y values. So this is the same thing. Our x and y values, we are actually going to graph these on the coordinate plane in 7.8. Okay, so there is a connection there. I'm talking about the same x and y values, except now I'm just, calling them something different, input and output, in reference to a function. All right, now the other bullet point, the first one, says that a set of numbers is only a function if each input has exactly one output. Well, here's what that means. That means if you had an input-output table, okay, and you had a function, what you see in red is what we call a function. This is, function 101, basics. Here's what it's saying. It's saying that given this function, y equals x plus 3, when I plug in my input or my x values, each one of these values I'm going to plug in for x to get an answer. So let's start with the first one. What is 1 plus 3? What is it? 4. Right? Fill in the rest of the chart now. Plug in each one of the other values and fill in the output value what your output would be. 5, then 6, then 7. You see the pattern? 5, 6, 4, 5, 6, 7. So let's just say for a minute though that we made an error in our calculations and we thought that our last output was 5. Well, there's 2 red flags here, right? It clearly breaks the pattern. And then also, it goes back to what we're saying in the first bullet point. Each input, each different input, can only have one output. So it's not possible for 2 different inputs to have the same output, right? You plug one number in, one number comes out. It's not possible for them to have the same one. That's what the first bullet point is saying. Each input has exactly one output. All right, any questions? Any questions?
What if you have a 10 instead of that 5 in there at the end? Would you be able to know that that was wrong?
Then it would break the pattern, so then that would be a clue to you that it's wrong. Okay, that's a great question. All right, so yeah, we need to go back to the correct answer. It would be 7. Okay, so now let's look at example 1. You have a couple problems like this on your homework tonight where you're just substituting the value into the function. Okay, so your function is y equals 5x. You're going to plug in the value that it calls for, and then whatever you get out of it, that's your output or your y value. So go ahead and try the first one. Make the substitution. Y equals 5x, so plug in 7 for 5. That's not 57, that's multiplication. Did you guys multiply it? Y equals 35. Who got it right? 35. Okay, so now that you've seen one, I want you to do the next one. So we take our function, we make our substitution, and then we get our answer, and that would be our output. So make my substitution. Y equals 5 times negative 3. So what does y equal?
15.
Negative 15. All right, who got it right? Negative 15. Good, more of you. Okay, so that's on your homework tonight. Now, in example 2, we're going to set up an input-output table. Okay, so I need you to go ahead on your paper. We're going to draw a big box, 4 columns. Okay, and then the first column is our input. And what I want you to notice about these values is that these are my common values that I'm going to use no matter what function I'm evaluating. This is a common set of input-output values. Okay, -2, -1, 0, 1, and 2. When you move up into pre-algebra, algebra 1, even algebra 2, this is a very common set of numbers that we use when we're evaluating functions. So now I'm going to take each one of these values and I'm going to plug it into the function that it's listed in my table, okay? So this function is going to change. Each problem, it'll be a different function that I'm plugging these numbers into, all right? So y equals -2 plus 4. And this is the part that there's no excuse to get it wrong, okay? And it's really a bummer because it's quite a bit of work when we start graphing for you to make a simple mental error like this. You have your calculators, don't get it wrong. What is -2 plus 4? You're kidding me. I just heard 3 different answers. What is it, guys? Really? -2 plus 4 is 2. 4 is positive, guys. It's much bigger. My output is 2. Don't get it wrong. Okay? Use your calculators to double check, but hopefully you can use mental math to know the answer to that. Now you just go down the line. Plug in the different values in for x. -1 plus 4. What's -1 plus 4? 3. Go ahead and fill in the rest of your outputs. Okay, so what's 0 plus 4? 4. What's 1 plus 4? 5. Okay, so now you should see a pattern, right? What's going to be my last output? 6. Okay, before even doing it. And so now in the last column, we can match up an ordered pair. We have an x value and we have a y value, so let's match them together. -2, 2. You see that? I took my x and I took my y and I put them together. Go ahead and fill in the rest of your ordered pairs. All right, so what's my next ordered pair? Everybody together. What is it? -1, 3. Next one, 0, 4. Then 1, 5, and 2, 6. Last chapter we learned that what can we do with ordered pairs? We can, I heard it, graph them. So that's what we're going to learn tomorrow. We're going to learn how to graph a function. So here we did our input-output tables. We came up with our x and y values, and we can take those values and we can actually graph the function. A function is always graphed as a straight line. All right, so that's where we're going with it. But for now, let's stick with just making our input-output tables. I want to do one more. I want you to do this one on your own. In example 2, I want you to make this input-output table. The only difference you're going to see is the function. Now your function is 3x minus 1. So again, you're still plugging in the same set of values, and you're going to see that on your homework too, that you use the same domain. It's just now you're plugging it into a different function. Okay, so we made our substitutions. Y equals 3 times -2 minus 1. Now be careful with that negative. I like to just kind of go down and make all my substitutions, then go back and solve. What is 3 times -2? -6. What is -6 minus 1? -7. Did you get -7? Did you get -7? Why not? Put it in your calculator. There's no reason not to get it. All right, now we keep evaluating. -4, -1. Do we see a pattern here? What's my pattern?
I'm subtracting by 4.
Nope, I'm no, not subtracting, but I'm adding 3 to each value. That's how I get my output. Then when I match them up with the ordered pairs, that's what I get. Anybody get all of those right? Okay, or the ones right that you did finish? Okay, so that's how I make my table, and like we discussed earlier, we're going to take these values tomorrow and we're actually going to graph them. Okay, so that's how we're going to make our input-output table. Now let's go over to example 3. In example 3, we see a step missing. Now, I know my input and I know my output, but I'm missing the function. I'm missing the function. What am I plugging my x values into? What equation, what function to get my y value? And here's the question I want you to ask. What am I doing to x to get to y? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? And by how much? I want you to look at all of these numbers in the table. Okay, look at all of them together. There's one specific pattern. What am I doing to x to get to y? I want you to try to find it. Mackenzie, what's the pattern? Very good. Did you see it, Loza? Did you catch it? I'm going to add 3 to each one. This one gives it away, 0 to 3. Okay, well, yeah, plus 3, and then I can test it. 1 plus 3, 2 plus 3, 3 plus 3. Yes, that is my pattern. So now I write it as a function. Y equals, what am I doing to x? I'm adding 3, x plus 3. See that? I write it as a function. Now I want you to look at the second set of numbers. This one is much more difficult, but I think that you definitely can get it. Last hour we had several get it right. Write it as a function. What is my function? How do I get from x to y? What am I doing to the x value to get to the y value? Now write it as a function. So since my numbers are clearly trending down, I'm either subtracting or dividing, and I can clearly see that all of my y values are half of my x values. So I know that I'm dividing by 2, and since my y values are all negative, it has to be -2. I can write it either way. Y equals x over -2, or y equals x divided by -2. I probably would prefer this way, but either way, I'd be happy if you got this answer right. Okay, so if you understand that, that's everything you need to know for 7.7.